Welcome, ladies and gentlemen. Today we're going to be talking about graphing exponential growth and exponential decay. All right, you're going to need your notes, calculator, and a pen and or pencil. All right, let's get started. So this first one, you guys don't write this down, okay? But I do want you to think about it and come to class tomorrow ready to decide which one you would rather have. So option A, if I give you $10,000 every day for the next 30 days, or would you rather have option B, I give you a penny today, but it will double every day for the next 30 days. So this is what the first 10 days look like in option A, and this is what the first 10 days look like in option B. So tomorrow when you come to class, you have to decide whether you would go with option A or with option B. We're going to discuss that. So this you do need to get written down in your notes, please. Exponential growth and decay. Things that grow or decay at an accelerated rate, okay, or at a certain rate. So bank account entrants are growing. Population can be growth or decline depending on what it is or where it's at. Okay, radiation, depreciation on your car. This one I'm going to stress so much for the next 2 days. Okay, never buy a new car. I'll put it in right now because it depreciates crazy amounts of value. All right, and then fossils, okay, carbon dating is a decline. So these are some examples of growth and decay, so jot those down in your notes, please. Now, you don't have to put this in your notes, but this is what we're going to be looking at. The one right here, this is going to be a growth, and this is a decay. All right, you don't need to put them down, but this is our general picture, what they're going to look like for our growth and decay. All right, now we're going to get started. So our exponential model, you guys have to write this down, please. It's going to look like this. Y equals A times the quantity to the x power. So our x value is going to be in the power, our exponent, okay? Now this is very, very important. Our general growth function is if b is greater than 1. So make sure we get this in our notes, okay? All of this slide has to be put in our notes. The b is called the growth factor because we're going to be growing. Our prices, our numbers are going to be going up. Exponential decay function is if b is between 0 and 1. That's really important. It's between 0 and 1. And b is called the decay factor. All right? So those are very important to make sure you have in your notes, okay? Now, this also important. Before we start graphing, you need to know what an asymptote is. So an asymptote is a line that the graph approaches more and more closely but never truly touches. So please, this right here, star it, highlight it, it has to be in our notes. Now if we look at this picture right here, our line is getting pretty closer and closer and closer to 3. So y equals 3 on this one would be our asymptote. So our asymptote, once again, is a line that the graph approaches more and more closely, but never truly touches. All right? Okay, we have 3 graphs for you. Here's the first one. Now, when we're graphing these, this is going to be really, really nice for us. We're just going to go x, y, and we're going to kind of go back to when we used to do lines. We're going to go 2, 1, 0, -1, -2. Okay? We're just going to plug it in our calculator. So when we plug this into the original, we're going to go 3 times 2 to the second power. And we're going to get 12. Here we're going to do 3 times 2 to the first power. And we'll get 6. Here we go 3 times 2 to the 0 power. And we're going to get 3. We're going to put it into the -1. So 3 times 2 to the -1. We get 1.5. Then we're going to do -2, and then we're going to get 3 times 2 to the -2, and we get 0.75. Now we're going to graph this one. So I have 2, 12, somewhere over here, 1, 6, 0, 3, negative 1, 1.5, negative 2, 0.75. So our graph is going to look something like this. Okay, since it's going up to the right, this one's a growth. So if we look here, this is greater than 1, so it's going to be a growth. Alright, so we're growing. This is where it becomes really important, you guys. Our asymptote is whatever is added or subtracted back here. Since nothing is added or subtracted back there, our asymptote is going to be y equals 0. So right here on 0, I'm going to draw a dotted line to represent my asymptote, what I'm going to get close to but never touch, y equals 0. Now I need to do the domain and range. The domain, if I can pick any x value I want, that means that my domain is going to be x such that x equals all real numbers. Now my range, if we look at this, my asymptote's at 0. So whenever we do our range, we look at our asymptote. If it's above it, it's going to be greater than. If it's below it, it's going to be less than. So our range is going to be y such that y has to be greater than, not equal to, because it's never going to touch 0. Okay? All right, moving on to graph number 2. We're going to do the exact same thing here, ladies and gentlemen. We're just going to go negative 2 to 2. So I have my x and y, negative 2, negative 1, 0, 1, 2. Plug them in. So here I'd have 2. Now this, when you type in your calculator, you want to put your exponent in parentheses. So parenthesis, negative 2 minus 3, and then minus 5. And we're going to get negative 4.97. And then if we type all these in, if we type in negative 1, we get negative 4.93. 0 is negative 4.88. 1 is negative 4.5. 2 is negative, oops, this one's negative 4.75, sorry. 2 is negative 4.5. Now, if we look at these ones are all really, really close. But if we look to see what our asymptote is over here, right here, subtracted, we have negative 5. So our asymptote is y equals negative 5. So when we graph that, that means we're going to get really, really close to negative 5, but we're never going to touch it. So negative 2 is negative 4.97. Then negative 1 is negative 4.93, 4.88, 1 is 4.75, 4.5. So it's very, very gradual way up, but eventually we're going to go up here. Okay? So there's my graph. We have to put in my asymptote, so I'm dotted line right here at negative 5. X equals negative 5. Now for my domain and range. Domain, once again, ladies and gentlemen, I can have anything I want. So it's going to be x such that x equals all real numbers. Now my range, my line is above my asymptote, so it's going to be y such that y is greater than, and then whatever my asymptote is, so greater than negative 5. All right, moving on to our last example. Here we go. If we look at this one, this is between 0 and 1, so this one's going to be a decay. This one's going to look a little bit different. So x, y, negative 2, negative 1, 0, 1, 2. Plug them in, so I have 1/5 to the negative 2 power plus 1. And I'm going to get 26. If I type in negative 1 to my exponent, I get 6. Type in 0, I get 2. Type in 1, I get 1.2. Type in 2, I get 1.04. So as we see, my asymptote is getting closer and closer, ladies and gentlemen, to what's back here, 1. So my asymptote is y equals 1. Put this on my graph. Negative 226 is way up here off my graph. Negative 1, 6 I can graph, so I'll put that one on there. 0, 2 is right here. 1, 1.2, put it about there. You guys, when there's decimals, just get it close. And then 1.04, it's like almost on the line, but not there. So our graph is going to look something like this, where it's going to get closer and closer to 1, but never going to touch it. So right here, we have to put in our asymptote. You have to draw it in every time. Y equals 1. Now, last but not least, our domain and range. Domain, once again, ladies and gentlemen, x such that x equals all real numbers. And my range is above my asymptote, and my asymptote is 1, so it's going to be y such that y is greater than 1. All right, that's all I have for graphs. This we're going to run through really quick. These examples you want to have down. You just have to identify if it's a growth or if it's a decay. So a growth, remember, is greater than 1. A decay is less than 1, but greater than 0. So 1.2 is greater than 1, so this one's going to be a growth. We look at here 0.3 on this one. We only look at what's being taken to a power. So the 0.3 is less than 1 but greater than 0, so it's a decay. If we look here, 3/5 is less than 1, so this is also a decay. And our last one here. Now this is still a fraction, but if we look at this, 7 divided by 2 is 3.5. And 3.5 is greater than 1, so it's a growth. All right, ladies and gentlemen, that's all I have for you today. Enjoy the rest of your day, and I will be seeing you soon. Bye.